Good afternoon and welcome to today's webinar, which is a live demonstration of the forming simulation and automatic blank development functions using LogoPress's ProgSim. The webinar is presented by Accurate Die Design software and hosted by Metal Forming Magazine. My name is Brad Coogan. I'm the editorial director of Metal Forming at PMA, and I'm pleased to serve as your moderator for today's session. Before we get started, just a few notes about today's go-to meeting. It is being recorded for archiving, and the recorded event will be posted to the magazine's website within the next few days. So we'll let you know via email when that recording is available for viewing online and sharing with others. Also, all the participants in the meeting are in listen-only mode. That means that the speaker and other attendees will not be able to hear any audio from your site during the program. If you want to communicate with us throughout the program, you can submit questions and comments using that question box, which is located in the right-hand control panel of your go-to screen. You'll simply type your question to an organizer as selected from the drop-down menu. Then you'll use that same question panel to ask questions of our speakers at the end of the presentation. All right, so let's go ahead and begin today's webinar. Again, which features a live demonstration of ProgSim performed on a previously created LogoPress strip layout. Today's presenters are Ray Prober, President of Accurate Die Design Software, as well as the company's tooling engineer, Paul Schomer, and Matt Gould, Instructor and Application Engineer. So Ray's going to introduce things and get the ball rolling, and then he'll turn it over to Paul and Matt for the demonstration. So please welcome Ray Prober.
Hello, everybody. Welcome to the webinar. Accurate Die Design Software, we're forming simulation and die design software experts, as you can see on the screen, and more importantly, as you can tell when you start working with us. We've been very blessed in having 20 years this year of selling forming simulation software, and that's actually 1 year longer than we've been selling LogoPress DieDesign software, so very fortunate. So today we're going to show you the LogoPress ProgSim. We're going to talk about some differences between different simulation softwares. ProgSim, I've got to believe, is probably the most affordable thing on the market, and there are reasons for that. There are some things that it gives up that other more expensive ones have, but for a lot of customers, and especially those that are already using our die design software or thinking about it, you'll see that it's extremely easy to set up because it's so well integrated into LogoPress. So AutoForm developed ProgSim years ago, and when they purchased LogoPress, I guess I can only assume that within weeks they were already quick at work getting the ProgSim developed, because they knew that there were a lot of companies out there that weren't in a position to be able to afford AutoForm's forming software because they do such small parts and maybe a limited quantity of them. So they wanted something affordable that the masses could use. So with that, let's get started. Matt, why don't you start showing ProgSim?
Okay. So here we have a strip layout that was designed using the LogoPress DieDesign software. I will start the ProgSim simulation function.
This is going to begin recognizing all the punches that were already created in here, and it's going to begin converting them into a format that it can read for the simulation. It's started with a list of some of the basics there, and you can double click on them to go in and edit and define each of them as you go. First one here is a boundary between each station so that you can divide the simulation into some manageable chunks. And so he just drew a line across the strip and told it basically the width of the strip and how much is in each station. Next step here is the pilots. This is just comes down to selecting any of the holes that you want to use for piloting. If it's a patterned item, you can hold control and it should grab all the rest of that pattern through the strip. see the pilots that it created there. Next thing we need here is a lifter, and this is mostly just to control how the material is going to be handled in each station. And it's basically just going to be a rectangle down the center of that's going to control the lift in an area that isn't being formed. Giving it a precise lift value rather than the generic starting value. Let's start adding the lower form tooling here. This is recognized the punches, the lower form punches that were already created in LogoPress. It is intelligently trying to grab just the surfaces that are actually going to make contact with the material. The less faces you have involved, the faster the simulation will run. And it's pretty good at grabbing just what you need. Do the same thing on the upper side here. You can see it's picked up some extra stuff. You know, it was unable to distinguish which one was the pad and which one was the punch. So he can redefine that there and then check and see which of the surfaces that it grabbed and see if you need to grab any more. Hit the check again and just see exactly which ones it did indeed grab. The last one here is the trim tooling, because it is starting at the regular coil. Should grab all your cutting punches automatically from the strip layout. So that's for all the basic tooling there. You can start adding more types of tooling from the left column there. He added a pressure pad, which is spring force controlled here. Again, it's kind of the same format of picking the surfaces that you want for it. You can define a stroke, and then you can either ask the software to calculate the amount of force needed, or you can enter an initial starting force to begin with. There's a second pad here. He's just letting those, letting the software calculate the pad force on those. Be putting in the press stroke here, the material thickness, the progression, and the material itself have been picked up from the strip layout. He is using the default medium friction setting. It's pretty good for most setups. And then with this kinematics view here, you can kind of see the tooling in motion beforehand. Upside down right now, actually. Just to kind of preview and make sure all the tooling is actually moving how you want it to move before you actually invest time computing the result. When you like how that looks, you can move to that computation tab. And we're going to run with the basic elastic plastic shell solver type. This is a good one size fits most type setting for the meshing and the calculation that's going to go on in here. And this is basically, it's taking all of the surfaces that we selected and all of the parameters that we fed them and exporting that all out to the AutoForm incremental solver. This is the same solver that runs in the higher end software, but it is, just the various limitations that are applied to ProgSim here. So it's running the same simulation, but it's helping you extract that from SolidWorks here and feed it into the AutoForm solver. It's gonna finish up our last two, I believe they're idle stations here. And it's gonna automatically kick us over to the results tab when it's ready.
I see the blank holder force increased. It knows to do that automatically.
Yep, that's correct. It was set to calculate the amount of force for it.
And if it realized that the pad is backing away, it increases it automatically.
Alrighty, so there's the whole strip. We've got a number of results you can look at here. The formability is kind of the layman's view here. It gives you a very easy to see, red is bad, green is good kind of result here that you can, show to anyone, and it's a really easy result to interpret. You can get in deeper, look at actual thickness or thinning, either, actual thickness values or a percentage of the original material thickness, same information being displayed. You've got plastic strain, the amount of material actually being stretched in there. You've got major and minor strain, the amount of forces in the actual material. Max failure is the formability result in a little more granular level where you can actually go in there and see how close to failure it is. Failure is a 1.0 value. So you can see if it's, is it just barely failing or is it really failing? Can we massage this to work or not? You can highlight wrinkles there. Basically compression and stretch in one direction leads to a high chance of wrinkles. And we can show a per station springback result here, showing it how much it's sprung back compared to the closed state of the press. As that showed there, show exactly each value on any node you select. And that information can actually be exported out as an STL file back to your strip assembly. So you can use that as a guide to adjust your tooling and try the simulation again. I believe this time now we're going to do the cut optimizer, and this is basically you turn on an option and select the station that you want it to analyze, and it is going to create a sketch around the perimeter of your part. Is a 3D SolidWorks sketch, and you can go into the sketch then and then determine how much and which portions you actually want it to attempt to optimize. If you don't want to, these holes don't need to be optimized, so he can remove those sketch entities. You can also choose how far up this the edge of the flange here, because it's going to be connected in the middle, so it can't optimize where it's being connected to the carrier yet in this station. But you can use this to work on just a little portion of the part if you need, one leg in particular you're working on, or if you want to optimize the part all at once. So we're optimizing just that blue portion. We're leaving the center alone. Gonna tell it how close we want to get to that value. So he's put 10,000s. It's gonna iterate through up to 5 times initial simulation again here. And then 4 more adjustments to the cutting punches that we fed in earlier, and it will compare that result to the outline we have given it here, and it will adjust as needed. It is going to take a little bit. It's running that full simulation that we watched a little bit ago. It's going to run through that entire thing there, so it's going to be 3 or 4 minutes, 5 minutes for this one. It's given us a plot on the left side of the deviation. When it finishes this first result here, we'll get our first data point of what is the farthest point from our target value there, and you can kind of watch the progress it makes through each iteration here. The real critical radius on this part is that moon shape down on the edge there. It's welded onto a pipe, so we need to get an actual round edge on that flange there. So it's going to go through these last 2 idle stations here quick. And then it's going to come back and compare to this target here, and it's going to adjust all of those cutting punches that we fed in initially. And it's going to send that new cut shape through this whole forming process again. Probably see the new cut. Oh, yep, 31 thousandths maximum deviation. We're already on to the form station again.
So this is the process where we're actually doing the automatic blank development. So while we're sitting here waiting, twiddling our thumbs, this is saving hours and hours out on the shop floor of putting it in the press and finding out how close it is or not, and then making adjustments manually by guessing at it rather than measuring it internally with, I like to call it an internal CMM.
See just the first iteration here, how much closer it is to that desired radius on our flange here.
Ray, do you want to take a question while we're waiting for this to finish up?
Yeah, that's a good idea. Let's do it.
Okay. Talk a little bit about the input formability parameters that you're using. What are the parameters and how do you obtain them?
So most of it's all of the tooling that you actually have pre-built in the strip layout beforehand. You know, your cutting punches and your forming punches. Beyond that, it's ideally tested material data going into it. You know, it's a little bit more than the tensile strength and that kind of thing that SolidWorks has. So it's a bit more involved getting material into the database for it, but we've got I think something like 100 materials in here already. And that's going to cover quite a few number of things. There's still going to come up, you know, some materials where you're going to need to get something tested if you want to have the best results possible. But there's also a kind of a certain amount of, you know, that steel's pretty close, and it's still good enough to give us a gut feeling about how we're at with this part, even, you know, without taking the time and money to get the exact material tested. Kind of depends how close you want to cut it on some of those, I think.
Yeah, right. So of course that leads to the next question, and it's a loaded question in a way. How accurate are the material properties? I'm sure it's going to depend on the material.
Right. I mean, for the, you know, most of the stuff that I've seen tested, this stuff's coming out of here pretty spot on. You know, if the optimizer coming back here and saying, you know, we're going to get it within, you know, 5 or 8 thousandths or something like that, that seems pretty close to what we're actually the actual in-die results here.
Yeah. Okay.
And I think it's important to note that this is, you know, AutoForm owns LogoPress, and so this is an AutoForm product that's being sold as LogoPress ProgSim. And so it's actually using the exact same database as AutoForm uses. And AutoForm is well known for having a very clean database, and some of the companies out there that, you know, they can't track the materials so well like AutoForm can. So anyway,
Sure.
it's a very clean database. And again, this is the AutoForm solver running, with some inputs and outputs removed. Again, they don't want to, again, there's other limitations, but there's not as many bells and whistles as AutoForm has by any means.
But it's still the same solver, the results you're getting are the same as you would get if you would use the same options in the full AutoForm.
Yeah. Okay.
So you got the little maximum deviation chart here showing that we went from 31 thousandths to 19 thousandths down to probably about 9 thousandths, 10 thousandths here. We got within our target, and so it stopped at the third iteration rather than running a fourth and a fifth. You could accept these results and then come back and run an even tighter tolerance if you wanted, or you could say this is good here. But you're showing the, it changes the line between green and red when it's within tolerance, but you can see around here that we are all within that 10 thousandths. That's pretty close to our desired radius on here. You can see the initial results here, how far off it was around there especially, but there are some places that were, within tolerance right off the bat.
Yeah, and this is pretty incredible. Metal Forming Magazine wrote an article in the May issue that we're actually just getting reprints of, and then a follow-up issue in the June-July issue. And we show a picture with a radius gauge in there on the original geometry that we sent them, because they built the die that way. We actually designed this die back in 2005 or 6 probably, and it's incredible. I mean, it's just spot on. It's crazy.
You can see here. No, go ahead. We're about to talk about the punches, so you can go this way too. The forming or the cutting punches are in the strip layout here are still the original SolidWorks parts, the LogoPress punches that were created initially. So to get the compensated cutting shapes out of that, you will need to go into the punches here and actually look at the sketches. And then there's the LogoPress Optimize the Cutting Punch outline, which will help you bring your AutoForm optimized cutting punch shapes out of there. And it's going to preview them here in purple. You can choose which portion you want to keep. Don't want to affect the heel here, so he deselected that. And then the rest of it is converted here into lines and arcs. Is working to keep tangency on it across the whole length of it. But it is created just as a regular SolidWorks sketch. So if you don't like how some of the end comes off here, you can use the regular SolidWorks sketch tools, put a fillet on, that kind of thing, because it's still 100% SolidWorks geometry on all of this stuff here. This was a little overlap where the two cutting punches overlap, so it wasn't as necessarily a optimized shape right there on the edge, but clean it up back with the fillets. And then the LogoPress strip layout adjusts all the cutting in the stations here, just as you would if you were editing the punch for another shape that you put in there, regardless of the optimizer. Do the same thing on the backside punch here. I'm gonna remove this back part again. Stick with the initial input geometry and then connect the new optimized geometry to it.
So just note the first part of this presentation, we were really looking at formability of the part. Is this part going to pass or fail, or are there going to be issues? And now the last part here is where we're doing the developing of the blank. So again, picture how much shop time is spent in and out of the press. And this is a very tiny, very simple part, but when you get into bigger parts, it's well worth doing on a small, tiny part as well. But when you get to bigger parts, it's just so much more valuable. It's incredible. But AutoForm saw the benefit of people that are just doing tiny parts that weren't going to invest too much money on a simulation software and bringing their software to the masses, as I like to say.
Looks like we got one last cutting punch to optimize here.
Ray, getting back to the material database, is it not the same database then as is in LogoPress?
It is, it's a different database. It's AutoForm's actual database. It's got a few more parameters in it than LogoPress uses, even for its, LogoPress is a one-step flattening prediction software built into it that is a very quick way to get some results out of it, but it's still not as in depth as this sort of simulation, and so it needs more parameters for this. It is fully linked between the two, so if you select your LogoPress material, it will automatically, when you start the ProgSim simulation, is going to pick the equivalent AutoForm material to use with it. I'm sure there's a few that don't link up perfectly, and it'll tell you, there's ask you to pick a material for it because it doesn't know what the best equivalent is from the LogoPress one, just because I believe the LogoPress is a little bit bigger yet than the AutoForm.
Right now I'm updating the cuts into the strip from the updated punches.
So we're ending up with an accurate strip assembly, accurate strip layout.
Yep, you'll be able to
with updated geometry.
see that's a little bit of sliver material that we essentially added onto the blank. This is more of a housekeeping thing here of hiding these bodies or deleting these bodies in the strip layout, just because they will be attached to the part now and they wouldn't actually be floating in space.
The LogoPress command to unsuppress that on the following stations, so it gets rid of all of them. And these are unrelated to those first two. It's in a different portion of the part.
There we go. Got a cleaned up strip ready to continue with the tool design.
Very nice.
Any more to show on this, Matt, or do we want to look at?
That is it. I guess we could take some questions.
Okay, sure. Yeah, so anybody wants to ask questions of these guys, go ahead and use that question panel on your go-to control screen. We do have a few questions. So you do need to create a strip layout first. Does that layout need to be created using LogoPress?
It's going to be easier if you start with a LogoPress strip layout, just because it's already got some of the parameters. It's already got the progression and the material thickness. It's already in the LogoPress database, so it's already got a material linked for it. It's going to automatically pick up the punches and things like that. You can do it without a LogoPress strip layout. It's just not going to be as efficient as it would if it was created in LogoPress. And if you're already going to have LogoPress, it should probably be created with it anyhow.
Yeah.
And if it was a different CAD system that you're exporting it into and importing it into SolidWorks and LogoPress, yeah, you absolutely can still use it. But again, it's just not nearly as efficient because things aren't being automatically recognized. But it's still, I mean, that's only the setup portion of it, you know. So, but otherwise, it's operating exactly the same, correct, Paul? It's just the setup of the punches and stuff that takes a little longer.
The setup is what's different. The simulation itself would be 100% identical.
Yep. But it runs in LogoPress, runs in SolidWorks and LogoPress.
Okay, thank you.
Mm-hmm.
So all the forms you showed were top down. I'm assuming you can do similar calculations running horizontal direction.
Yeah, you can define cam motions coming in from the side. You basically just need to create a plane and say my motion is perpendicular to this, and then you can define how far and the timing and the pressures and the various aspects on different angles. It's just for the sake of a little format like this, some little basic vertical tooling is better for timing.
Right, okay. And ProgSim also calculates all the forming forces, right?
Yeah, that's actually probably worth opening up the simulation again here. You can see all the forces per tool, per station on the whole tool. It's actually got a little toggle result here. It's got a little chart across the bottom here. These are all the forces required to basically amount required to form, amount to hold the pads locked on still. You can toggle on each of those forms, and it'll show you the force on which station it's doing it on. If you hit the element checkbox next to like upper pad or something.
And yeah, we can't underestimate or undersell, so to speak, the fact that it's automatically increases the force when it sees it needs to. So you can start out with 5 pounds of force on something it's going to take a lot more than that, but it's a way of, like Paul tells people, you're not wasting money on springs then, because you're not guessing at 5,000 pounds when maybe you only need 1,000 pounds.
Right. All right, so then the question that we have from one of the attendees on the pressures that it wound up calculating for the pressure pads. It's not what we're seeing, is it? Can you show the pressure pad? Pressures.
Yeah, there you go. Yeah, and that's the amount of force required to hold that pad still 100%. It's not going to back off in here. It's going to tell you how much force you need to hold it locked.
And that's not to say that it wouldn't potentially work with something less, but especially when you get into thinner panels, when wrinkling is going to occur. But on something like this, if you had less, it wouldn't stay perfectly flat. It would start bowing the part up. That top portion of the part. When AutoForm sees that part is start to move, it keeps pushing down until it doesn't move anymore. Is that a correct way of saying it, Paul?
Yep, that's correct.
Okay.
Yeah. Can you predict shear break?
No. That's more of a solid simulation kind of thing. And even I think some solid simulation softwares aren't looking at the shear and what the break is going to look like, and if you're going to have a double break and so forth. And that's one of the things with a shell solver. There's 2 different types of forming simulation. One is a shell, which is what AutoForm and ProgSim and most brands of software are using shell solvers. So you're not, I don't know how to say it other than you're not looking as closely at what's happening during the thickness and edges and things like that. It's still incredible what it does without using the solid, knowing that it's going to rip here or there or wrinkle, etc. But again, with a shell solver, you're not being able to see those kinds of things.
Okay. Did you start this with the finished part and then use LogoPress to unfold it in this particular application?
Yeah, that's the standard LogoPress strip layout workflow. You start with the formed part. You use the LogoPress unforming tools to work back to the flat blank, and then you're creating the stations for the strip as you go on the way to the flat blank, and then you can run the LogoPress strip layout command. It'll arrange them all out for you, put spacing between them and all that. And then you can start creating your punches around that.
And so this was, the initial blank on this was done that way, Brad, as far as we use what we call the LogoPress blank portion or the LogoPress flatten portion, the FEA one-step software for determining this blank, and that's what we fed into it and built the strip around that. And that's where you saw it was on this part, it was still relatively accurate. You saw how big the slivers were, how big the areas were that, I guess it didn't show you where it added on, but you saw where the leftover material was. But on some parts, you start to get a little bit more complex parts, and it can be incredible how much time it saves going in and out of the press.
Yeah. Okay, still got several questions, but we've got plenty of time left too, if the audience still wants to ask questions of these guys. Yep.
We've got some other parts we could show too. But let's keep going with the questions. But we got some other parts to show that we've done simulation on.
They're still coming in, Ray. Does the software calculation account for adding shear to the punch for tonnage reduction purposes?
It does. That's not related to ProgSim, but yeah, when we do a strip layout with LogoPress, absolutely, that the forming tonnage is reduced when you put shear angle on the punches.
Okay. Can you simulate the roll benders? Those ready bender type tools.
It's going to take linear motions of your tooling only. It's not going to do a rotational form.
Oh, okay.
Good question. Good question.
How about coining?
Coining is, akin to forging. That's something that you would need a 3D mesh for. This is pretty, kind of the industry standard shell or surface type mesh, and it's just not going to handle coining at that level. It does have the thick shell solver type, mesh type on the computation. It's one of the other settings you can check. It will try to account better for the coining that you get, from like setting radii and that sort of thing, but it is not going to be something that you could try to smush an area thinner on your, like electrical contactor or something like that. You're not going to be able to handle that kind of coining operation with this sort of software.
Yeah,
so
and even
somebody would ask about price, and so do you want to talk a little bit about the pricing of the?
Sure, no problem. I guess I won't get into exact details, but it's extremely affordable in that it's single-digit thousands of dollars. Feel free to reach out to us, and I'll tell you the exact price and send you a quote, whatever you'd like. But yeah, it's extremely affordable. I don't know that anything touches it. It's pretty crazy.
Yeah. So actually, do you want to give out your email address, Ray, in case somebody wants to?
Oh, sure. It's Ray, ray.Proeber, PROEBER at accurate DieDesign software.com. Also, DieDesignSoftware.com works as well.
Okay, thank you.
Mm-hmm.
All right, so somebody's currently using NX and their strip layouts run through AutoForm, from which we receive the trim sheets, surfaces, et cetera, used in the designs. Is there a way to use LogoPress for surface compensation or spring back issues that they run into during tryout? What would be the best way to integrate LogoPress into an NX design, or is it even something that should be considered? That's a pretty good question.
Well, I guess, again, if you took that NX design and exported it as a step file, you could import it into SolidWorks and LogoPress and run ProgSim on it, and it would show you the spring back that's taking place.
Okay.
Yeah,
Yeah, go
I
ahead.
was gonna say it's a better iterative loop when you're doing the strip inside SolidWorks here, in that you can kind of do your back and forth then between compensating your form punches as needed to produce the shape, going back to NX or another, CAD software, and then back to SolidWorks where would certainly take some time, as opposed to working on the strip layout in LogoPress and SolidWorks initially, and then you could take your strip layout after you had optimized all the forms and everything, and then you could go to NX or another platform and design your tooling around that strip that you had developed in LogoPress. That would probably be the better workflow, rather than trying to go back and forth continuously during the initial development process.
But again, I'm first and foremost a die maker, and I don't like to oversell things or undersell things. And he said something about, I think, or he said in the question something about that he's running his stuff through AutoForm now, and he had questions about Springback, and AutoForm should be doing exactly the same thing as we're doing with Springback. So it's because again, this is AutoForm.
Right.
On a smaller scale, and that's I'll let me share. That's one of the AutoForm doesn't want to cannibalize their main market by coming out with ProgSim, so there's a size reduction in it as well. So it works with parts that are fit within a 12-inch bounding box.
Sure. Okay. What about going back and optimizing older tools using ProgSim? Is that something that's possible?
Yeah, we've done it. And that, Matt, could you just bring that PowerPoint into view?
Sure.
And we'll just show you a few of the parts that scroll down. So these are, I don't know, I think there's at least a dozen parts here, and some of them are pretty cool. You just saw this one, and there's a couple different images of each part. Keep going. There's that, and another one. And here, this is a better, and this I think is one of the images in Metal Forming Magazine. So, and it's really cool, and it's impressive. Again, I get, I don't want to say goosebumps, but it's one of those things, it's a boring thing to most people, but man, I get pretty excited because it's crazy. Okay, next one. Yeah, that was crazy. That's a nice picture. I mean, that's just wild. Okay, next. So let's just run through a few of these quick, and we'll keep going, Matt. This is one. I designed this in 2002, and I knew nothing about 3D. And oh my gosh, I feel so bad to this day, 20 some years later, what I did with that guy, that, what he went through. So I think one or two of the other slides might show keep going, Matt. That's a good sized part. And now we run that in ProgSim, and the wrinkling that went on. Next. Yeah, here, some of these pictures. Oh my gosh, look at you go down to number 6 or number 3, and then down to number 4. Look at the wrinkling that's going down underneath there. It was a disaster. And again, shame on me. I knew nothing about 3D at the time. 23 years in the career, I'd done nothing with 3D stuff, and I got quite an education starting with this part. So yeah, and now, so the next, I don't know if we even showed, but I assume the next one or the last one, maybe the number 6, is where we modified it and got it to work. But here, look at some of the stuff that was going on with this. And so again, I didn't talk about that. Any simulation software, even one-step software, but especially the incremental software products out there, they just do so much for educating your workforce so much faster than you can. People look at me and say, "Wow, you really know a lot about this stuff." And I say, "Well, yeah, because I've effed up so much stuff over so many years, And but here, seriously, when you're quoting stuff, even you can get these educations, and you can go through so many more parts. And again, you get so much smarter a lot faster. Somebody today, they'll learn what I learned in 40 years in 10 years. I'm not exaggerating.
There's a part that you can kind of see the X-ray through your tooling. You can actually, stop at a 1/4 inch before, the tool closed, and actually see the overlap starting to happen. And you can start to see forming, if we hit this leg a little earlier, then that wrinkle wouldn't be happening out there, versus in real life, you can only see the closed, or the open state of the press, and so it went from one state to the next, and there's just a jump, and you don't really see how exactly the material flowed versus being able to actually see the movements happen here is really eye-opening on some parts.
Yeah, in fact, this one, Matt, if the top picture above that arrow a little bit, that pressure pad along that entire angular surface is a little bit shorter. The flat portion of it is shorter. And now if you go down to the next picture down, that flat portion is longer, and that's why it caused it to bubble up so much more right there. Because if you look, the pads are in about the same spot. And so again, there's so much that can influence it, and you're influencing it in minutes rather than in days, because you've got to cut metal and then try it, et cetera, et cetera. Okay, next image, let's go down a little quicker. Yeah, go down. Yeah, there's the part, and yeah, it turned out really well after they got done fixing what I screwed up. Down. And this is a cool one. You've seen this part probably before. We used it in ads and stuff, but this is one, again, it's just incredible how accurately it predicted the blank, because we've got these parts. Almost all of what we show, I've been very good about getting samples from people, and like the amount that's getting trimmed off. There's the failure that went on and the failure that's going on there. But on the top right side, Matt, the purple flange, the topmost purple flange on the right, the one to the right, that one, there's a lot of material there getting trimmed off. But if you move on to the other side of the part, there's very little material getting trimmed off. And so when we look at this, the first time we fed into ProgSim, say, oh my gosh, it's incredible how well it matches. Because again, we've got the parts sitting here in front of us. Okay, next. Yeah, there, that's what, go back to that other one. That's what I was talking about, the overlay. See how there's just a little bit of shiny material when you overlay it over the part that they ran 15 years ago compared to the finished part. There was just way too much scrap on that one side. And today, this is a great example. Today, and there's a big cutout in between this thing. We left plenty of material because that's what the customer wanted us to do. But if the volume was right, you could pay for this die in a couple years by simply using ProgSim to fully develop this blank and not trim away any of that material in the die. It doesn't need to be, especially for what this part is. So yeah, it changes the way you do business. Next. Yeah, this is another one, and this is one this is a very unfortunate part. This was a great company, really good guys. They just weren't quite up to technology, and they didn't plan for this, and oh my gosh, there was a big problem. That's a big tear in the part. I don't know if we show the actual part with the tear in it in this slide or not. Yeah, look at that. Oh my gosh. So yeah, that's that. Again, I'm a tool and die maker, so I hate to say this kind of stuff because this is kind of stuff a sales guy would say, and I hate being called a sales guy, but man, I've seen parts where not doing simulation on parts before, 2 minutes worth of simulation would have saved a company $100,000 in one case. Yeah. We've got other cases where there's $30,000 of money sitting on the table, or that you had to pay out. Next, we got just a few more. We got a dozen. This is a cool part. We did this in 2002, 2-out die. This is really neat. And there was no failure on this part, but it's extreme thinning. In fact, you can show it. See on the strip there, Matt, you can see the red. There you go, the minimum 22, the real thin portion. So yeah, that was a neat strip. And again, the blank development on this, we did this in 2005. And oh my gosh, I was scared. I have no idea what that blank looks like. Are you kidding me? And some people are a lot better at it, even without using any kind of flattening software. But it's just, you're just building a smaller die because you're not planning for so much material waste. There's that thinning. You can actually see it visually even. That's that 22% thinned area. Next. Oh, this one, another nightmare part. And in both of these, I actually saw, this one I saw in the simulation that this was going to happen even in one-step software. And the customer wanted to move, not the customer, but the customer's customer wanted to move forward with it, and is okay. And so I think there's probably a picture of the failed part next. So there, the left-hand side there. Oh my gosh. And again, think of what that costs to now have to go back and completely changes the blank development, et cetera. Next. This is a neat part. This is a customer that really good shop, a wonderful, wonderful shop today, and it was then. But they wanted to form this down without any draw pad. And I said, okay, but we're going to leave room for one just in case we need one. And sure enough, you need a draw pad bad because look at the edge quality and stuff, you know. So once you put the draw pad on it, it's beautiful. Next. And that one, you know, look at the angle going on there. And again, simulating or developing that blank, oh my gosh, that's a big job. And when the software is doing it in a matter of an hour or two, you know, letting it run for that portion of the development is crazy. This is another one. This one I feel very bad for the customer. This was a $30,000 loss. We actually did the strip for them. We didn't do any simulation on it, but the failure was really bad, and it ended up they had to change the whole process of what they were doing, and after months. Yeah, there you can see the fractures again. Just some of these are. You know, as a die maker, you're sad for the companies. It's too bad, but again, it can be avoided today. This is a cool one we did. We did this one just for kicks. We've done this one years and years ago, but it's just neat. There was no failure on this part, fortunately, but it's a neat one to simulate. Very cool part. And this one, again, I think no failure on it, but it was a nice simulation we did on it. But yeah, we've got at least 10 or 12 that have failure, and we absolutely reproduce it. Yeah, another really cool part. Transfer die designed in 2002 or 3.
Can you guys go back to that number 107 part, if you know which one that is? Somebody does have a specific question about
107.
a wrinkle issue at the 90-degree form.
Might be the first part on here.
This one?
Oh, might be the first part if it was 107, I think.
Oh,
I don't remember a 107. There's a 202.
there
there
it
we
is.
go.
There you go.
Okay, yeah. Okay, yep.
So the
Yeah.
question is about the wrinkle issue at 90 degrees.
The wrinkle issue?
The 90-degree form in 2 directions. That's what he says.
90-degree form and 2. Maybe he's talking about the nose out there, but I'm not sure if I see wrinkles. I don't know that was a problem actually.
Oh, okay. No, yeah, I'm sorry. He clarifies here that it just explains his earlier question, I guess, about the forming in 2 directions.
Okay.
Sorry about that.
No problem. Yeah, we're just about done. We just got 2 or 3 left, and we're done.
Okay. What about fold over? Extreme, compression causing fold over conditions. That's something.
Well, you saw that in that one. Oh yeah, let's just look at this. I think this is the last one, and then we'll go back to the fold over question. So this is cool. This is in the June-July issue of Metal Forming Magazine, and this one I'll just state. This one is usually you can't match up the failure nearly as much as this. A lot of times in any simulation software, this one just kind of coincidentally, you can see that crack on the right. It's just crazy how well that matched up. But a lot of times when a part starts to fail, no simulation software, I think, very little simulation software out there probably does show you exactly where the failure is. They'll certainly show where the thinning is. They'll all be the same with that, or the ones that are right will show you where the thinning starts, but exactly what the crack looks like, this one might always be a flyer, because again, once cracking starts, it's hard to determine where it goes, and it's really not so important to see where it goes. It's important to know when it starts. Okay, one more. Is this the last?
That's it.
Okay, good. Okay, other questions, Brad? Do we have more?
You wanted to look at the fold over on this one right
here.
Yeah,
Right here. The fold over. Yep. Yeah, so this is one, like I said, we've sold other simulation software in the past, and I remember a customer, a very, very good customer, and I might have mentioned even earlier, I remember the owner of the company just saying, putting me on the spot, and it had a suitcase corner like this. He said, well, this is no good. This doesn't show me that there's any fold over. look at the part, and here the part was doubled right over itself. So this does a very, very nice job of seeing that. But this is another tip for people, regardless of which simulation software you use now or plan to use in the future. But it's one of the most important and overlooked things in looking at simulation is how to view the results. So it's important that you look at it through the steps like this, and especially through the last 10% off the bottom. So in fact, the new, and I think maybe probably any simulation software can do this, but I know the new product we started handling in the last couple of months, Stampak, their templates are set up for, I think, probably 95%, 96%. So when you're getting really close to being closed, because if you look at it at 100% closed, it's mashed it flat, and with most simulation software, you can't tell that there was a major problem that you're not even seeing.
Okay.
And in this case, it doesn't show it being mashed flat, but again, some of them it does.
Right. Okay. Spring pressures, gas mechanical spring pressures. So they increase on deflection. Do the values provided only show that final or on contact pressure needs?
Correct. It's just a final pressure. It is not doing what do you call it? A gradient pressure.
A pressure rise. Yeah, I don't know that it's
Right.
looking at the pressure rise. It's just increasing that pressure until it's not, till it's not wrinkling anymore.
Right. Okay. Can you simulate extrusions?
It's another forging operation.
Yeah, no, and this is where, and again, there's a ProgSim webinar, of course, but our business is selling DieDesign software, LogoPress, which we've sold for 19 years now, and the ProgSim for the last few years, and we've recently started handling a new product that is in fact a 3D. A solid mesher as well as a shell mesher. So it'll do all of this because this is faster, but today anymore, it's incredible what they've done with speed, both on shell solving and on solid solving. So it's very, very fast, and it will do things like coining and extrusions and just crazy how it does it.
Okay. I think this refers to the original demo. Is the 12-inch bounding box for the finished part or the entire strip?
That's a really good part. Whoever had that question, Matt, scroll if you can find it quick. The big one, the Wally's 2598. That one. So this one, I'm thinking this is probably, what's that?
Find the real picture.
Oh yeah, there you go. Oh, thank you very much. Great, thank you, Paul. So yeah, you can see this part is just about 12 inches, and that was one of my first questions when they were developing it. So I was thrilled to hear, no, it's got nothing to do with the stretch webs. It is just the finished part.
Okay.
Very good question.
And we're going to make this the last question because we're at the top of the hour here. After running simulations and building the tool, and if the part doesn't quite match spec, is there a way to input a scan or a CMM result to resimulate the tool?
No, that's going to be something in a higher level software. This is, I think you'd have to go up to the full-blown AutoForm for that sort of thing. But this is just going to be.
And whether or not they can, I'm not sure they can. Maybe Paul, you already know, but yeah, I mean, that's certainly. And again, maybe I'm biased in this because they own LogoPress, as you know, they own ProgSim. ProgSim is their product, but yeah, they're pretty much the leader out there for simulation software. That's for sure, especially when you're talking about just shell stuff.
Right. Okay. All right, fellas, great job. We've reached the end of our time. Thank you to Ray and Paul and Matt for really was an outstanding and really nicely detailed presentation, and to our audience, thank you for attending the program.
Yeah, thank you so much for the great questions. Really good questions.
Yeah, great interaction from the audience. So again, we hope everyone found it a valuable experience. And as I said at the beginning, if you joined us late or you just want to watch this over again, we will have the recorded presentation up on our website. soon, probably later today or even tomorrow. You'll get an email from us when it's available for you to view it and share it with others. So again, thanks to the team at Accurate Die Design Software.
One last thing, if I could jump in there. This is the backdrop of our booth. We've got a 20-foot booth down at FabTech, so if you would please check us out. Paul, do you remember it's on our website, the booth number?
Ooh, not off the top of my head, sorry.
4410, I don't know. But yeah, look us up.
All right, we'll see
stop
you
by and see
in Chicago next week. And
Yeah.
for everybody that's attending FabTech, make sure to stop by and say hi to these guys. All right,
Thanks.
everybody have a great afternoon. You can close your browsers now. Thanks for joining us today.
You as well, everybody. Bye.